Okay, so my name is Theofilos Manitaras. I'm working at CSCS at the user support group. So today I'm going to talk about continuous integration in Jenkins. So my talk is going to be divided in two main sections. The first one is continuous integration in Jenkins in general, and here are the subsections I'm not going to go into detail now. And the other one is how we offer a CSCS CI service with Jenkins at CSCS for software for projects that include software development. So I'll start talking about what Jenkins is and what continuous integration is in general. So continuous integration from a software development perspective is a practice according to which the code changes that happen into the code base are continuously integrated into the shared code bases in the master branch. So the main thing is that each contribution to the main code repository is tested by an automated build, and here is where Jenkins comes in. And you should take advantage of CI practice because it helps you catch errors sooner and avoid code conflicts as much as possible in the future. So Jenkins is an automation server which is open source. It's written in Java and is used extensively for CI. And it's easy to use, and its success is mainly because of its extensibility via plugins. So you can customize it to your needs, and this makes it ideal for various development scenarios. So just to say to you that when I'm talking about Jenkins in this talk, I'm referring to Jenkins 2, which is the latest major version and has adapted to the pipeline as code approach. So how a typical CI workflow looks like. So first of all, in order for the continuous integration to make sense, of course, your software project has to be version controlled, for example, via Git. And a typical CI workflow consists mainly from the following steps. So each developer belonging to a team works on his own fork of the software project. So when you need to submit something to be merged in the master branch, you submit a pull or merge request. And the above code change submitted via the pull request triggers an automated CI job. Here is where Jenkins is notified so that it starts building and testing. So this Jenkins job runs the unit tests and performs further testing if you want to make sure that there are no bugs introduced by this code change. Then the results of the CI are reported. Optionally, the developers can be notified. Jenkins has various plugins so that you can be notified for the results of the build. And finally, the proposed change is merged either by the administrators or by automatically, if you have configured it so, which can further trigger a deployment job or something like that. So there are various ways to install Jenkins. Here I list the 3 easier ones. So if you are familiar with Docker, you can directly, and I will show you after how this works, you can pull the Jenkins image, which is offered from Docker Hub, and then run it using Docker. The second way is to download the var, which is the web application archive, and run directly. You need Java 8 installed on your computer to run that. Or alternatively, you can use the package manager of your Linux distribution to install. So when you install Jenkins, you go and access the web UI for the first time. Jenkins asks for the unlock password, which it gives you at the command line interface, and Also, if you forget it or you want to do it after you have finished with that, it gives in this path where you can go and find it. You put it here, and then Jenkins asks you which plugins you want to install. So if you are familiar with Jenkins, it's not your first time you install and you know which plugins you are going to use, you can go and select them. So otherwise, you should go with install suggested plugins. So Jenkins knows which plugins more or less are the most critical and the most widely used and installs them for you. And this is how the screen looks like when you say that I want to install the suggested plugins. And then you have to create the first admin user so that you can manage the Jenkins installation. And here is how the screen looks. We will see those steps in detail after in the live demonstration. So this is what you see when you try to connect to the Jenkins web interface. And this is what you see when you want to create a Jenkins project. Those are some typical project types that Jenkins offers, which can be extended. More project types can be added depending on the plugins that you have installed. So here I will talk about the 3 easier plugins to work with, easier project types to work with. So the first one is the folder, which basically is a Jenkins way to group together projects that belong to some certain repository or are related somehow. The pipeline, which is a general pipeline as code-based project. So I'll talk about what the Jenkinsfile is after that. So this can be used by pulling the Jenkinsfile from the source control management, or can be directly written. You can directly write the build steps that you want in a corresponding text box that Jenkins offers. So the last one, which is the easiest one if you have your version hosted on GitHub. So this is the GitHub organization, and it automatically allows you to incorporate GitHub projects which already contain Jenkinsfile and make them trigger Jenkins build depending on the options that you select. So I talked before about pipeline as code. So at the core of this pipeline as code approach that Jenkins brought is we have the Jenkinsfile. So the purpose of the Jenkinsfile is twofold. First, it describes in a domain-specific language and with certain steps that Jenkins provides. It describes the necessary actions that will be performed by the Jenkins builds when a job is triggered. And second, by having a Jenkinsfile inside your project, tells Jenkins that this project is a valid Jenkins project which can be tested by Jenkins. And a Jenkinsfile which describes a pipeline can be written using 2 alternative syntaxes. The oldest syntax is this one, the script the pipeline, which is basically a Groovy-based script that describes the actions that Jenkins will take when the job is triggered. And this is the newer approach here, where you don't have to know Groovy, and it's more easy to follow this declarative approach based on simple constructs specific to the Jenkins actions that you want Jenkins to take. So here, I compare the 2 different Jenkinsfile syntaxes. The first one is the scripted pipeline. Here you see more or less that you define your stages. Stages group together steps that are somehow related, so that you can have steps related to your configuring. You can have steps related to build. You can have steps related to testing. And so you can group them together to stages. And node here is the Jenkins terminology to tell it that I want to run. I will tell you what a node and the corresponding agent here is, you tell Jenkins that I want to run on this particular node, and the same for agent here. And here are your steps. You see here that in a different stage, you can have a different node, so these steps can be run on a different node at a certain stage. And for the declarative pipeline, you have this pipeline. Here I tell it that I want to run in any available agent. So the first one that is free, Jenkins is going to run to it. And here I describe with the stages block, stage 1, and the steps. And here we have the steps that are to be executed in stage 1. And here go on with stage n. So I talked about nodes and for the declarative pipeline agents. So the Jenkins master is, in Jenkins terms, the system on which we have our Jenkins instance installed and running. And this is not intended to run any jobs since it poses a security risk. Now, a node in Jenkins terms is any system that can execute Jenkins jobs, and it can be a remote machine where Jenkins can log in via SSH. It can be a virtual machine or even a Docker container. An agent is how declarative pipeline, this is used by the declarative pipeline terminology to refer to any non-master system which can execute Jenkins jobs. So we'll see later how we will define nodes, and they can be managed either by the Jenkins admin or users which have the corresponding permissions. You go to manage Jenkins, manage nodes, we will see that later. So I talked before that inside the stage you may have certain steps, and I will show you some important steps and how they look like, what you can do with Jenkins. So here you have the dir step. So with the dir step, you can more or less have dir. Here you put in double quotes your directory, and the steps that are included in these curly braces are going to be executed inside the mydir. If this mydir is not available, then Jenkins is going to create it and execute these steps inside there. A useful command that is usually combined with dir is delete dir, which, if it is executed inside the dir block, it recursively clears this directory. Then you can add environment variables that will be valid for some particular steps. You have here with env. This is valid for, as with the dir step, the with env is valid for both scripted and declarative pipelines. So here you specify in a groovy list syntax, the environment variables and its values. So the steps that are executed within the with env block here will have access to these environment variables. So as I say here, you have to use a list syntax with a square brackets, and you define your environment variables. Then comes the sh step. So this is the Jenkins way of saying that I want to execute something with my shell. Here you see in the scripted pipeline inside the node block, I have sh, and here I specify, this is how you can specify multi-line strings, and here are the commands that I want to use. And the one nice feature is that the first line can be a cbank line to tell the sh step with which shell or which language, it can be Perl, Python, you want to execute these commands with. It's like the first line that you put in a bash shell script or a Python script. And finally, I just added here the post-processing that is available from a declarative pipeline, where when all your steps have finished and all your stages, based on the actual status of the build, you can have, depending here, you see post. This action will happen always, what is included inside the curly braces here. This is when the status of the build changed. You may have a failure before, but now you did some change and the build passes, so you are notified. You can put some actions here that your status have changed, or the other way around, you made the change and the build now fails. Here, when the build is successful, you can execute some commands, whether it fails, whether it is unstable. So I decided not to give you the scripted pipeline, which is a little bit more difficult, but this functionality can be achieved with a try-catch finally block that Groovy uses, which is similar to what Java uses. And based on the current build result, you can more or less decide what action you need to take. But this is more difficult, and you need to know a little bit of Groovy of how to do that. So I didn't want to mention many other steps. There are many steps, and depending on the plugins that you have installed, further steps can be introduced in the pipelines. And I didn't want to give any other steps because you have this nice feature of Jenkins. Whenever you want to find the syntax of a particular step, there is this pipeline syntax I will show you in the live demonstration, where you go and you select the step that you want to execute, and more or less each step, when you select it, it gives you the input that it can take, and it says to you what the output is. And by pressing generate pipeline script, it generates the syntax for you, which you can take and paste in your Jenkins script. So whatever you need in terms of how a step is written, or what input it takes, or how should I write it to be a valid pipeline step, you will go to the pipeline syntax, the pipeline snippet generator, and it gives the step for you by introducing what your input and what output you want. So Jenkins plugins, as I told earlier, one of the advantages of Jenkins over other CI systems is that it offers a very large number of plugins. I checked, and it's more than 1,000. So more or less, you can customize it to your own needs. And here I have some useful plugins which we use here at CSCS. One of them we don't use, but I will use it to show you how Jenkins works. So this is the role strategy plugin. It's very useful if you are a Jenkins administrator, because you can specify users' permissions with a role-based approach. So you can give particular roles to different users depending on the project. So for one project, a user can be only able to read the project and see the builds. And for another project, he can be able to create new builds, to create new types of jobs, etc. And then the Blue Ocean, this is one of the latest plugins which more or less changes how the web UI looks and gives you in a more graphically and a more interesting way how the pipeline looks, and I will show you how the steps look in the Blue Ocean. Here is the GitHub pull request builder plugin. Here in CSCS we use it extensively because it allows us to trigger pull requests based on, to trigger Jenkins job based on GitHub pull requests. And also we can change the behavior of what build is triggered based on the actual pull request title. And I added here a question mark because this hasn't been updated since some time, but I just added it because it's useful. And we have the mock agent plugin, which I will use when I demonstrate to you, because it allows you to create dummy nodes in your local host, which is very useful for testing Jenkins and seeing how the node functionality and the agent functionality is used. And plugin management is performed by navigating to Manage Jenkins, Manage Plugins. Also, it's nice to talk about Jenkins credentials. So Jenkins allows the creation and management of credentials through the credentials plugins. If you select the install suggested plugins, this is already included. That's why I didn't add it to the plugins before. And there are certain credential types that you can store on Jenkins, and they can be used by it and by its jobs. So it's the typical username with password. You can have a Docker host certificate authentication. You can have a SSH username with private key, which we use a lot for logging into nodes that execute our Jenkins jobs. You can have a secret file, a secret text, a certificate, and credentials can be grouped together under a credential domain, and the global domain is available by default on Jenkins. So now, as I said before, in a typical CI workflow, when a change is made by someone and it is pushed, and he wants to merge it to the master branch, a trigger is built, and so a Jenkins job is starting to run, and then you get notified by the results. So there are various ways that you can trigger a Jenkins build. So here are the most common ones. By adding extensions and plugins to Jenkins, you can have more types of build triggers, but those are the commonly used. So build after other projects are built. So as I said before, you can have a Jenkins project, a Jenkins job, automatically be triggered if another Jenkins job succeeded, for example. So you can have a build job that will automatically merge a pull request if it's successful, or it will deploy the newly generated artifact if you want after something is merged. It can deploy it to production. Build periodically. This option triggers a build under a specified schedule. You give a cron type syntax, and you have a schedule where the builds are triggered. Poll SCM. This option polls in a specified time interval the source control management for code changes, and it triggers builds. You can tell it in particular which branches and which repositories to look for. You can give in regular expression syntax which one to look for. This is one triggered by webhooks, where you trigger a build using webhooks. For example, you can specify from GitHub webhooks that are related to certain GitHub events. So when, for example, a pull request is made or a merge takes place, this can generate a webhook which will notify GitHub and will start a build. So let's go now, before I go to how we use here the Jenkins CI at CSCS, to demonstrate a Jenkins workflow and how it is used. So I will go on. Let's see if you can see. Okay. So I will. Can you see it, or I will make it? It's okay now? Okay. So I will use Docker to start with a Jenkins image, which is more or less like installing Jenkins for the first time, because it will ask us for the admin password. So I do docker run. Here I specify more or less the Jenkins run typically in port 8080. You can change that, but here I specify that I want Jenkins to run to my local port 5000 to connect actually the port of the container to my local port. So I will be able to access it in port 5000, and here I will give the name Jenkins test, and here is the actual image that I want to run. I choose the tag. If anyone is familiar with Docker tags, here this is the LTS, which is basically it will pull from Docker Hub the long-term support Jenkins. If you don't want to use the long-term support, but you want the latest and greatest, you can leave it without the tag, so it will go to latest. So I will start this. So this starts our Jenkins server. So here you will see that this is the password, the admin password. This is the admin password that it will ask us to put. So if I go now to access so here it says unlock Jenkins. We have the admin password. I'll go and paste it here. I will continue. No, we don't want to say. So install suggested plugins. So it starts installing the plugins. It doesn't take long. And after that, I will show you also how to install manually another plugin. So more or less, these are the plugins that are typically used. You see there that it will install the SSH slaves, the Git, the pipeline, so the credentials. So take less than a minute. So this is the process that you will go on also if you install Jenkins locally. If you install from repositories, for example, the first time you access, you will see this. You will give the admin password, and you will install the plugins. Any questions to now? Yes.
I don't know where the microphone is, but it didn't work before, did it? I'm not familiar with Docker.
Yeah.
So it's all a bit kind of black magic to me, but I can just download Docker and I can try Jenkins out on the laptop.
Yeah, yeah.
Exactly.
Yeah.
Just do a Docker run and
yeah.
And so I can experiment with adding support to my
That's why I wanted to do this, because I have a local Jenkins installation which I will use to show you. But with Docker, it's easier because you don't have to do anything. You don't have to make.
It's all already.
Yeah. You don't have to make special Jenkins user to be able to access it and
so when
stuff
you
like.
go Docker run blah 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 Jenkins, that's going somewhere out there. On
It will go to Docker Hub, which the Jenkins creators have a keep registry where they update, and it pulls the image, and it will start running Jenkins, and you can access it like that. So I connected more or less the port to the inside port of to the internal port that the container runs. So, okay, so here, create first admin user. Okay, not something. So, save and continue. So here is where you can tell it to run somewhere else if you want, which can be changed later. So Jenkins setup is complete. Start using Jenkins. So now we are logged in as administrators to Jenkins because I was the first user that I created. So I will go and install some plugins as I told you. I went here is where the magic happens. when you're at the main page, you do manage Jenkins, and it has all this stuff. First, I will go for the plugins, as I told you, manage plugins. Here you see updates. Of course, there are no updates available because we installed now. So it always installs the latest versions available. So I will go to available, and I will check for Blue Ocean here, and the mock agent that I told you, and I marked those two, and I will tell it download now and install after a restart, and I will check restart Jenkins when installation is complete. So typically it works even without restart, but because Blue Ocean is a major installation which includes further plugins, you see here how many plugins it needs. It's good to do a restart so that you can start fresh. So you see here that it downloaded. Those ones are pending, but it's not really that great. It goes fast. So what I'm going to do after these plugins are installed, I will configure two mock nodes to more or less replicate how you would have nodes on Jenkins, which could be remote machines, virtual machines, or even Docker containers to run stuff. And this is where the actual steps will take place, the actual steps of the pipeline. So you see it. It's a number of plugins that are installed, so the typical plugin installation doesn't take that long. I will enable also auto refresh here. So you see it's restarting here. It's ready. So I will go and log in. So you see that now nothing is at the queue anymore because everything was installed. So now I will go and create my nodes. I go to Manage Jenkins, Manage Nodes here, and I add new node. You can see, right? Is it big enough? You go to new node here, and you see if I haven't installed the mock agent, only this permanent agent would be available. But the Jenkins menu is extended when you start installing the plugins. So I select and I say node 1. And the executors are more or less how many slots these nodes have for Jenkins jobs to execute. So if you have many Jenkins projects which are going to use node 1 both at the same time, then if you add more than one slot, it will add available slots to Jenkins so that these two steps can be executed in parallel if they both need node 1. And now the label is another way to make distinction between the nodes. So I save it here, and you see node 1, it launched directly. If it's a remote node, it takes some more time. But you see here, now node 1 is available, and it has two executors. And I will create another node. Now I will do copy from existing node. I will rename it node 2, and copy from. You see node 1, it knows from before. I select it. I change the label to node 2, and I press save. So this is being launched. You can see the log here. Yeah, this is a Unix agent, etc., etc. So now, if we go at the main Jenkins screen, we have our two nodes set up, and we can start creating our jobs. So create new jobs here, generally you go to new item instead of new jobs, new item. So as I told you before, I can create a folder to organize my projects. So test folder, okay. So I can add the description. So now I'm inside, you see here Jenkins test folder. If I go on top, you can see it here, test folder. Of course, last success is not available and last failure, etc., because I haven't run anything. I go inside, and I can create now credentials, which I will use for my GitHub account to connect it, which are specific to this folder. So I go to credentials, folder. Here is how I go. And as I told you before, the domain global is available. And I add credentials here. So here are the various types of credentials that are available from the Jenkins side. So for GitHub, I will go with username with password. And I will put my GitHub credentials. And with the description. Okay. So now I've created my credentials. I go back to the test folder. And here I will create a GitHub organization type of job. So I go to new item, and I say GitHub organization. And I will say this is my username on GitHub. GitHub organization, OK. And now I'm presented with this screen. So what I showed you here is the easiest way to specify, to create a GitHub organization and more or less configure Jenkins to start running jobs from a GitHub project that you already have. So if I go here to credentials, now you see these are the credentials that I created before. So I add this. Owner, it says my username here. So what I'm going to add now is that here is my GitHub organization, and I have made a fork of this project. So let me just, okay, I will. So if I don't specify anything now and I click apply, it will search all my repositories that I have under TOJO in my GitHub account. But I don't want that, so I can do here, you see the behaviors. So I can add filter by name. You can give a regular expression. Here we don't need. Okay, and so I will remove discover branches. I will, because I want only pull requests to be executed. And here, the current pull request revisions from pull requests from origin, which are basically the pull requests that are made from origin to origin. And these are the discover pull requests from forks. These are pull requests that are made from forks of origin to my origin repository. And this is which pull requests it should trust and generate builds, because we don't want anyone from a public repo to do a fork and trigger a build. So from users with admin or write permissions. So only users which I have given admin or write permission to my repository, can more or less trigger a Jenkins job. So this is the pipeline Jenkins file. I already have a Jenkins file in a pull request that I will show you. So this is what name it looks for the Jenkins file, which basically contains the steps of the pipeline. Here I leave default because my default is Jenkins file. And here is scan organization triggers, which basically I tell it how long should it scan my GitHub organization. So typically this is something like a day, or you can give even more. But here, child scan trigger, this means how often it will scan for code changes in the already discovered repositories. So this, for this reason, I will put to 1 minute, and I will do apply, save. So you see, here it said all that. So it found Theofilos Manitaras, which is my name on GitHub. It found all these projects, but because I told it to look only for this name, it found this. It found the Jenkins file because it met the criteria of the Jenkins file I told it. And so if I now go back, this is my organization. Here you see it discovered this, and it has discovered the pull request, which is basically the first pull request I made to this. So if I go in here, it's a pull request I created for this, which basically only prints the path environment variable, and it saves to an output file. So this was successful. So a better way to view it is to go here that we say Open Blue Ocean, and you will see how the pipeline looks like. Here I go to pull requests, and here is my pipeline, which basically contains the steps. And you see, first it checks out from version control to get the latest source. Okay, so then I told it, give me the environment and export it to output. Here I print the path, and then I tell it to archive the output, and then to delete the kernel directory. And I can go to artifacts here, and I have the output, save, and if I look into it, it's more or less the environment of the node that was running. So I can go and show you how the Jenkins file looks like in this pull request. So this is a very simple one. So I have an sh step which basically does the env and outputs to a file. I print the path, and I archive this output out. And this is something we don't need. And you see here that this, more or less, was all checks passed. So Jenkins directly says to GitHub that the tests that I have specified are passing. Yeah.
The tick
yeah.
that appears, is that because Jenkins is a trusted source of ticks? Like GitHub already knows about Jenkins?
Because I gave my credentials to Jenkins, it can connect to this.
You're trusted, okay. Right.
Yeah, so I can go to.
I remember how it works, yes, because it's you use your
So
identifier, and so it.
So here I have my Jenkins file. No, this is not it. here you see this is my Jenkins file. If I do an error, and I push the change to my repository, so this branch is related to that pull request that you saw. So if I go here, you see add the bug, and if I go to Jenkins, now we'll go back to the normal mode, and if I go here, you will see soon that it will trigger a build. Come on. And you see, it triggered the build. This is number 2 build, and if I go inside here, you see that this build failed. We can go to Blue Ocean, pull request, no such DSL method, print n, okay. But the nice thing is that if I go now to Jenkins, you see, if you to GitHub, not Jenkins, it says that
this works because it's your repository, your credentials.
Yeah.
Everybody's happy. Yeah, fine.
You can make it work even if it's not your repository, but you have to be a trusted member of that, and you have in order for the build to be triggered, you may not have to define because it will be triggered in your own Jenkins. You may not have to define the credentials, but if you want to make it right back, you have to have right permissions and the proper credentials, because otherwise it will tell you that it cannot communicate back to notify about the result of the build. So I will also show you how some builds on my local Jenkins installation works. I took the CMake example that we made here, but here you see it's a different organization. I took the one that we had at ETH CSCS, so I added as an organization, not my personal organization Theo JGO, but I added this, so it even got the badge from GitHub. I go here, software development course, and I have pull request, and if I go here, you will see something that is more interesting. Go to pull requests. So here you see something with more steps, which basically is a configuration step, which I do CMake. This is CMake that we do dash dash and all these flags. This is where the code is built, so it's make install. So you see here all the specified stuff, and here is where the tests are happening. Make test. So I have the result of my test here, and I also say that the build is finished. So I can show you how this looks like from a Jenkinsfile point of view. So I have pull request here. This is the pull request that I was looking for. So this is a slightly more complicated pipeline, but more or less what changes is that I now tell it that I want to run on agent with a label node 1. So you see before we specified node 1 as a mock agent, And because we said that this will have also label node 1, all the stuff from here and below, if I don't specify otherwise, are going to run on agent node 1. So you may have different agents with different stuff that you want to run. You may have an agent with a particular Linux version installed. So there you have to do some tests there. But for another agent, it will be an agent with Unix, and you will have to do other tests there. So you can specify which tests and with which parameters to run based on the particular node. And this can happen also when you use Docker.
If you don't specify the agent?
If you don't specify, you have to specify agent any, for example. So if you don't have any particular requirements, the first available node that it might have here, all are free now, but it will decide which one to run to. So if it's...
Can you have agents with GPUs, agents without?
Yes, of course, because you can even combine labels that you may have an agent with GPU plus AMD, for example, or GPU plus NVIDIA, and combine labels so that you specify that I want to run in a node that have labels both for GPU and both for NVIDIA, for example, and it will run there.
Okay, can you go one stage further and say, on all the nodes with GPUs, add the flag minus GPU, and on the node which doesn't have a GPU, just don't add the flag? Or would that be
so you can do that, but in that case, it depends also on the particular Jenkins installation, because you have to know more or less what nodes the Jenkins installation has to say that I want to run with the GPUs and stuff. And when you want to run more complicated stuff, you have to go to the scripted pipeline where you can have proper for loops and stuff, and you can manipulate. So if it's something standard, more or less the declarative pipeline covers you, you are good to go. But if you have a pipeline that is more complicated, like the one we are using, for example, I will show you a Jenkins file that we have for our production repository here at CSCS. So I can go to Jenkins, and here are different Jenkins files depending on which Jenkins project we need. Some other are triggers for with pull requests in mind. Some other are built periodically. I will show you how a more complicated one looks. So here is a more complicated pipeline. So more or less you can add, I don't want to stay in particular steps, but you can add whatever logic is good for you, but the pipeline needs to go to scripted because this allows you to have Groovy inside and have the support of Groovy with proper language constructs, while the other one...
No idea what Groovy is.
It's a language that is good for building domain-specific language stuff. So this is why they chose it. So yeah, basically you can do what you said, but it needs more effort from you and a more customized Jenkins file. So this particular Jenkins file also takes stuff from here where we define environment variables and paths and everything. So this can read from other files, or it can also depend on libraries written in Groovy, which you have in another source control management. It can become very complicated. But for a typical, more or less serial step manner, this is fine. You see here, I have the dir. So in this step, in this step, I don't have to tell it go there and mkdir, cd and stuff. This dir tells it that everything that is included here will be executed in this directory. So this build, if it's not already there, it goes and creates it, and it cds into it, and it will execute this here. And here is the post, as I told you. I tell it, no matter what happened with the build, I want you to say that, OK, build finished, and recursively delete the directory. So because this is not in a particular build, but rather inside the pipeline, it will recursively delete the directory that agent node 1 is using at the moment. So more or less the workspace directory that Jenkins has. So if you have any other questions, or else I can continue with how we use Jenkins here for the CSCI service. Any other question? No. OK. So after this, I'm going to the second part of how we use Jenkins at CSCS and how we offer it as a CSCS CI service based on Jenkins. So because of the nature of the HPC system and of the queuing system, it's a little bit more complicated and needs a particular attention when you're writing pipelines and you want to run things to pitch-dined. So CSCS has started offering a CI service based on Jenkins, and it was announced last year at the PASC conference. And the very important thing is that you need to use this service if you want to test something on pitch-dined, because if your application needs to run on pitch-dined, you have to test it on the actual environment that it's going to run. So in this case, the local installation of Jenkins does not cover you, and it cannot make sure that when you actually transport, take your code and run on pitch-dined, it's going to run without bugs. So you can have a specific Jenkins file defined for pitch-dined, and you can have a specific job on the Jenkins CI service that we provide that can run some job to test actually on pitch-dined. So in our Jenkins offering, there are Jenkins slaves that are configured to submit jobs to pitch-dined, and therefore the software is tested on the actual software and hardware environment that it's going to actually run when you run on scale. So if you want to access the CSCI, the PI of the project that you are part of has to open a ticket and ask for access to the CSCI service. So as I showed you before with folders, now I am responsible for handling the Jenkins CI service on part of CSCS. So I will create a folder that will be associated to your project, and when you log in, you will only be able to see that folder. So there's no problem messing with other people's jobs or people messing with your jobs or seeing the job results and stuff. So as I showed you, credentials can be added inside the folder, so you can add GitHub credentials that will be only accessible by you and or your user in particular, or your team, whatever you need. So you can configure GitHub as I showed you, and these credentials cannot be accessed by someone outside this folder. And each project is assigned a Jenkins node, in parentheses slave. It's an older terminology that Jenkins used, which will run the corresponding Jenkins jobs. So you will use agent and the node name that we will give you, so that you know that this runs on the particular Jenkins slave. And finally, your project will be associated with an account who can more or less SSH on this slave and trigger and run the jobs, because you cannot log in as your user to this Jenkins slave and run. So we didn't want a user to be able to log in and trigger jobs and have something happening that might disrupt other users. So these are completely separated so that users are staying unaware of each other. And also another important thing is that this is meant not to be used to run jobs at scale, so you don't want to run to 4,000 nodes. You need to run with small node numbers. This is just for testing. So because this Jenkins user is associated to your project, it's actually going to take compute node hours from the project. So it's supposed to run something that runs very quickly and runs on 1-2 nodes. It's not use to run something at scale. So how you use the CSCI service, I will show you also live how you can log in. So because this Jenkins is not available on public, you cannot just say, OK, CSCI service and log in from anywhere. You have first to create a local port for working with SSH via ELA. So you do this command. And then here is your local port that you will use, in this case, 7000. And then by using this, you will have access to the CSCI service. So this is what you see when you try to log in. And you use your LDAP credentials that you have for your CSCS account, and you log in. Here I show you, for example, a user of project S299, what he sees when he logs in. He sees this folder. The other ones he cannot see, but as I logged as admin here, I could see the other ones. So, but he can see only this one, and then he can create a Jenkins project inside this folder. And the best practices that you should use is to adopt the pipeline as code and basically include the Jenkins file in your Git remote repository, as I showed you before. And because the Jenkins slave is not actually a login node of pitchDyn, we didn't want that, because if you generate many jobs, then the login node might have many jobs to run, and it will become slow, so we don't want to disrupt the users. So the Jenkins slave is basically a virtual machine that can only execute sbatch. It cannot do salloc, srun, and stuff like that. So you basically have your script inside your Git repo, and you tell it sbatch dash wait. The wait is used to make sbatch wait for it to execute the script. This submits the scripts and wait for it to be scheduled and executed. Because if you don't use that, if you do use sbatch without wait, sbatch will return immediately, so you cannot check from the Jenkins side the results and stuff. It will just continue with the next steps. So this is better than just taking the job number and just doing a polling every now and then and seeing if the job is finished and stuff. With this, you do sbatch wait, and this only returns and continues with the next shell steps when your job is finished. So we have also a special partition for one-node jobs, the CSCS CI, which you can use in your sbatch script, and this has higher priority and is mentioned for, as I told, one-node CI jobs, and this for your job to be able to be scheduled and finish more quickly than the other ones. And because the Jenkins slave does not have access to Scratch, it's only there as a medium just to do sbatch. If you want the output of your job to be visible outside Jenkins, you either have to copy it on Scratch or make use of artifacts to store the output or error files, which will be transferred back to the Jenkins web interface. So, as I told before, there are various ways to trigger a Jenkins job to start executing. So webhooks is one of the best ones, but would not work here since our Jenkins is not on the public web. So we have an alternative, polling a remote repository, and we have here, and as I told you, it's not available in public. I will show you also live how this works. You can say poll SCM, which basically polls the source control management, for example, GitHub, and if a code change is made, and depending on what filters on your branches you might have, it triggers a Jenkins job, and here is, this means in the cron syntax that Jenkins uses, that it will poll the source control management every 5 minutes, and if it finds code change, it will trigger the build. And another one that I mentioned also in the plugins is the GitHub pull request builder, which basically also is based on polling, but it will trigger jobs based not on branches, but on pull requests on GitHub. So in order to make this work, and on your question before, for this plugin to work, you need to invite this user, which is the Jenkins CSCS user on GitHub and is associated to CSCS, and it needs to have read and write privileges to your repository. That does not mean that it can merge smart. It does not need to have admin privileges. It just needs to be able to write so that it notifies you on the result of the build. And you enable, when you install the plugin, you enable this on your job. And it needs some more advanced settings if you want. This trigger phase is here a regular expression. So basically, you can add a comment in the pull request you want, and this will re-trigger the build. So for a pull request that no code change is made, but you probably want to rerun the results to verify something, to rerun the job to verify something, you can say, OK, test this please, and this will start running again. This will notify GitHub pull request plugin to start running the test. And this is another phrase that you can use. If you don't want to test this build from Jenkins, you can say that skip, and this will skip the build. So this is the cron tab line here again. This means that every 1 minute, this is going to check if there is a change or a comment made by your side to trigger a job. And here I have added in images how this works. A build is triggered for a new pull request. I made a simple pull request. This says that all checks have passed, and I can re-trigger the build by saying retest this please. You see here it started running again. Here again you see. And as I said before, you can basically restrict who can trigger by doing a pull request, who can trigger a Jenkins job. So in this case, purposely, I told a colleague to do a pull request to the repository, but I have not added him to the whitelisted users that can trigger a build. So you see Jenkins CSCS, this is GitHub pull request builder running as the user that I told it, because I have given these credentials for it, and it is asking if someone who has admin rights for the GitHub pull request builder can verify this patch. And if I say test this please, this will tell GitHub pull request builder that this patch is verified by someone who has privileges, and it will start running the build as you see here. So I have added some additional topics here I have listed that are more advanced, but it's good to have them in mind. So you can, Jenkins, I have said that how it can be used for continuous integration, but it can be used for continuous delivery and continuous deployment as well. You can use it and either use containers as agents or build new images and deploy them. Sorry. So you can use it via the Jenkins command line interface. It has a REST API that you can use to trigger jobs, to list jobs, do whatever you like. There are certain aspects that need a whole presentation to cover about how you can secure Jenkins. And also, it's very important if you have a Jenkins installation to look a little bit on Jenkins backups, so you can back up everything, and when you move it to another computer or something happens, you can basically reinstall Jenkins, and this will start from the state it was when the backup was performed. So you will not start from the beginning to put passwords to start new projects and everything. Everything will start from when you did the backup. And also I added some stuff. I will add this presentation to the GitHub repo that we have for the course. And the Jenkins user documentation, of course. They offer also they call it Jenkins Handbook, which basically is like a tutorial that has many things that might interest you if you use Jenkins. Here is a very nice book, which basically is a must-have for someone who wants either is a Jenkins admin or wants to dive more into Jenkins pipeline and see more complicated stuff. And this is another book. Those are both new. This is the Jenkins 2 up and running and the Jenkins fundamentals. These are links that you can search for when I add the presentation. So thank you for your attention, and I will show you now how the Jenkins CSCI looks from our perspective. So as I told you, first I will have to create, let me find it. Okay. So I will do this in my command line. I'm now port forwarding from Ella to 7000, and here I have already now I use my CSCS credentials. So here I have created a folder specifically for this, and I will show you how a pipeline looks like. So yeah, this failed, but this is the valid one. So here it's a little bit different for the CMake, but basically they are the same steps that are just included in an SBAT script. So you see here, this is the output and the tests that have passed. And here you see also the output of the batch job. And
that one, what you're showing there, looks like somebody's doing a CMake configure.
Yeah, I do, because they have to be done from the SBAT script. I do it all inside the SBAT script.
But scroll back down. It says installing as well.
Yeah, I
so
do everything.
That means I could do a build and then an install and then configure and build another project that depends on it to check that the install is all.
Yeah, but since I included everything in one SBAT script, because I don't want to have three different jobs submitted to the queue.
So it would be difficult if you had project A to do an install and project B to check that that install was.
You can do that, but you will need to submit another job, or you have to include it in the same SBAT script.
Because sometimes the build is okay and the config is okay and all the tests.
Yeah, I know.
Messed up somehow that when you
I know.
build an external
The thing is that this slave that is used in particular here, I will show you. Here I have some slaves which are used, which are associated to the projects that are using the CSCS CI project. So this, for example, is associated to us, the SCS Dyn VM1. This is not a proper login node, so it doesn't have any modules, any programming environment, nothing. It does support SBATs only. So we do that because we don't want jobs to be able, Jenkins to be able to trigger jobs and start building stuff with make J24 in the login nodes, because everything will be will break. So this does not have CMake installed, so you cannot do the configure and install in the login node and then just submit the job. You have to do everything from the SBAT script. But if you want to test that a build is successful, you have to test either inside the SBAT script by your own functionality, or have another stage submit another job, which will depend which will Jenkins execute if the first build stage is successful, etc.
I mean, it would be quite feasible to have a stage which just configure, and then a stage
Yeah.
and then a stage install, stage which builds something else against that install.
Yes, before, but now everything has to be submitted with an SBAT script.
But all within one script.
Yeah, so that's why I did it here. And
how many projects are using our CI here?
I have 6 or 7.
Oh, so not that many. Okay.
Yeah, it's more or less new, and many people have also their own custom solutions. But when they want to test on Dyn, it's the only way to do that if you want CI. And so here I have the output, which I can view directly here. So this is the output that you saw before. So when you do artifacts, it transfers directly to the Jenkins master from the node. So you don't need to do a copy or something like that. It knows from the command that it needs to archive this. So yeah, so this is how you can use our service, and I will show you also how this would look like. Software management course, pull requests, CSCS Jenkinsfile. So here I have the Jenkinsfile for CSCS, and I have the SBAT script here, which basically does the CMake and stuff, whatever you need. And if I go again to the test pipeline, and I show you how it's configured now, you should see this is a pipeline type of project. It's not a GitHub organization, so I have more control to it. And you see GitHub project. It uses a GitHub pull request builder, which uses the credentials, these credentials, the Jenkins CSCS, which you cannot see, but you can use. And here, more or less, is what I told you about the pipeline. You have the pipeline script from source control management. This means that the Jenkins file is available inside the remote repo. Otherwise, I can define it here. You can directly write it, but it's not a good strategy. It's better to have it version controlled as well, because if something changes, you can track the change. And you see here, I tell it a different Jenkins file name so that it can find this Jenkins file. And so, as I told you before, you can put other triggers as well. I can do poll SCM and put a schedule. And you can trigger builds remotely from scripts if you want, or use the REST API. You can build periodically. You see the schedule here I can put, or I can tell it to build after other projects are built. And you can specify also when to trigger the job. So you may say that I want to test my pull request, and if it's stable, then another project. It is one project that is called my build, for example, and if this is successful, it will trigger a second job that you have configured with another Jenkins file, which will deploy your software, or it automatically merges and deploys and everything.
Would that second, like if you say trigger the second one when the first one completes, if it's green, effectively?
Yeah.
Would that be in the same repository, or is that?
Yeah, it can be the same repository, because you can have many different Jenkins files. And
so you can have multiple Jenkins.
Yeah. So you can say that the Jenkins file deploy is the one that contains the steps necessary to do the deployment.
An automatic installation. If
yeah.
it passes everything, and then it just
Typically, that is the situation that you may have, for example, a Jenkins build that it may try everything and it will build a container, and then you will have another build that will deploy this container to Docker Hub, this image to Docker Hub. So everybody has the new Jenkins image with the latest code changes, the latest Docker image with the latest code changes.
So supposing I want to build my project with CUDA, without CUDA, and with networking and without networking, and then I want with CUDA and with networking and without CUDA and then when that number of options gets more than 3 or 4, it starts to become a pain. How do I specify things like, I mean, do you have to have a separate Jenkins file for different configurations? Or?
No, you can have in the same Jenkins file, you can tell it, but then you have to go to the scripted, so you can have more or less a for loop with the different configurations, so that based on the parameters, you can deploy this to a different GPU node, an MC node, some node.
Could I effectively have 4 builds with 4? Because what we have with our current system is we have, let's say, 10 different builds of a particular pull request, and all 10 have either got a tick or
so
a cross.
what I didn't.
They're all generated from one kind of script.
What I didn't show here is the concept of parallel stages, where you can have, for example, 10 different configurations, and you may have 10 available nodes or 20 available nodes which support the different configurations. You can send all these stages in parallel to build, and you can tell Jenkins if all of them are successful, then proceed and do what you want.
I don't mind if they're all done at the same time, or if they're done, like one could be done now, one could be done in a few hours, but if I want with CUDA, without CUDA, with this, without that,
that's
all these options, one tick for each of those.
That's what we do in our production repository, because the modules we build are meant for different machines. So based also on the GitHub comment, on the GitHub title, on the pull request title, we say which machine we would like to deploy this to. So the Jenkins file has the complexity inside, and makes the corresponding choice that I want to take this. So it reads the corresponding paths based on the machine and the corresponding option that it needs, and does the SBAT scripts which deploy in the proper machine. And to do that, it uses the correct Jenkins slave, Jenkins agent. So more or less, you can have logic inside the Jenkins file, which can alter the way the builds work and the stages work, and which stages are valid or not, based on what you need.
And do we support triggering builds on machines outside of CSCS?
If you can have access to a machine that you can basically SSH and create a node that you connect with SSH credential, then you can use it. What is needed from the side of the node is just to have Java installed, because Jenkins sends a little file, which is a jar file, which is more or less the Jenkins worker. So it doesn't need to have Jenkins installed. If it has Java 8 installed, it sends on the fly this, and it runs.
Okay, some serious security issues there, but that's okay.
Yeah.
You assume that the other people are happy with this.
You assume that because you do the SSH thing, you will be as your user, and you will not. But that's why I said the security is completely different. It needs a presentation and many presentations on its own, because it has many aspects in terms of how you secure, how you deploy your containers, because you may have a bug inside and some other people will pull it and have a bug, and how you make sure that the container is secure. There are other steps that can be intermediate, that you check that your container has everything secure and the image is secure and it has the latest software patches inside before you build, and then trigger the final deployment build. There are many things that you can do. And that's why there are many plugins available. I mean, if I go to this, this is the container still running. So if I go to the main page and manage Jenkins and where is it? Manage plugins available. There are some, and you see even it says to use for some plugins that they may have a security vulnerability and stuff. But there are, you see where I am in the.
It's a lot.
Yeah, for anything that you might need, you may find a plugin. Yes.
Just one comment. So the statement that you just made, just to clarify, for CSCS users, we only support running on this time. So the thing that Del just mentioned, that we could also run on any other system, this is for the internal Jenkins that we have, that it's only tolerated, and it can use other systems, but for the official service for users, it's only this time.
Yeah.
If you want other systems, then you need to discuss internally, go through security.
But
I'm just curious as to, in principle, because we have the Americans who are building our stuff and they want to test it on their machines, and if they could submit results back to the same, I mean, it's really all about just having the results on one dashboard. And I couldn't care less where the builds are going on, but seeing everything in one place so that you know it's failing in the US, it's passing in.
so what actually can happen is that you have your GitHub, and like that it notified that this test passed. You may have many different Jenkins instances running stuff. So I would say Jenkins from CSCS, build successful. Jenkins from site 2, not successful. So you can go to, you can have many notifications there, like that the one that you saw in your project.
Look on the GitHub one though, is having a dashboard with all the stuff displayed in one
Yeah,
place you can kind of.
That's a little bit more tricky when you have many stuff. But if you have access, I mean, to a remote machine, not secured by something, you can use it as a Jenkins slave. You can have a virtual machine of your own.
Would Jenkins SSH into a remote machine using the Jenkins credentials or using my credentials or someone else?
When you create a node, you can use. You create a credential which this node is going to use when it acts as a slave.
Gotcha.
So the credentials can be used in many places where Jenkins Jenkins can put credentials in. So it can be source control management, it can be a slave, it can be something else that a plugin needs, whatever. So, any question? Other?
Will you upload the presentation?
Yeah, I will upload. Yeah, but the thing is that I wanted to show something from the beginning so that everybody can install even in their own machine. And if they have a GitHub repository, you saw the GitHub organization. There is another type of project that you can, and there are plugins also that work for a Bitbucket organization. So it's the same. You give your Bitbucket credentials, and Jenkins starts scanning, and when it sees a Jenkins file, it realizes that this is a valid Jenkins thing that can run, and it will import the project and whatever. So there are plugins for GitLab for.
So the Jenkinsfile also supports.
So the Jenkinsfile, does it support to have different compilations, like with different options? So if my project supports being compiled with double support and float support, or
Because you have the sh step, which is more or less a shell step, this can execute anything that you might want from a shell point of view. So whatever you would have in a Bash script or a Python script or whatever, you put, as I showed.
right, but I would have only, I mean, maybe it would succeed for float but fail for double, and I would like to see that as two different things in the dashboard.
You can put it into different stages and basically have a variable that you put inside the script.
Okay.
And because it supports variable substitution inside the syntax. You can put on one stage the double and the other stage the float, and you can have two different stages, and you can see what succeeds and what not, and you can have this nice view of float, double, and one is green, one is red. You can see.
Okay.
So it's all a matter of what you define inside the Jenkins file. You can have very complicated Jenkins file if you want to, and that's why it's good to have it version controlled and not put it directly inside the text box as I showed you, because when it starts becoming complicated, you will see that you may have a syntax error in the Jenkins file point of view, so you have to fix it, and it's better to be version controlled. So, okay, thank you.
It's 2:30, so
Yeah.
let's have tea, and then we'll do Spack afterwards.